Hey, everybody. Welcome back to the I Believe podcast. I'm your host, Danae, and I'm actually joined by a guest that we've had before, back in the early days of the I Believe podcast, at least for me as the host. I think you were interviewed recently by Megan, our co-host, and she did like a kind of like a What's Up doc on her. But this is Dr. Lauren Dalvin, and she is, I believe, at the Mayo Clinic, correct?
Yeah, that's
Um,
right.
and you're in the Midwest, but I'm blanking on where.
We're in Minnesota, and I'm so happy
Okay,
to be back.
Minnesota. Yeah, I'm so glad to have you back. So, if you guys remember way, way back, any of you guys who listened to some of the original, the OG listeners of the I Believe podcast, you guys will remember that Lauren has been working on a project that she called the Living Library of Uveal Melanoma. And we just wanted to get an update. I think it's been a few years. We want to see where you're at with this research and what new developments do you have to share. So, Lauren, I'm just going to kind of take it your direction, let you have the floor so you can tell us all the good stuff.
Thank you so much. We have been doing so many exciting things. One of the things that I would really love to talk about is we have tried to expand our initiative, and I'm trying to use some of my expertise to grow this well beyond the walls of Mayo Clinic, ideally. So I know you know Justin Mosier very well, and so we've been working with Justin Mosier and a Here Insight. Some of you may have seen the call for tissue samples and information donation to the Insight Biobank. So that's been a really exciting thing for us to be able to use some of our expertise on building models so that we can hopefully grow this into something that really has a big impact across the country and is hopefully a resource that's available to all uveal melanoma researchers.
I think that's amazing. It's so cool. And I love, like, even just in its new launch phases, we're seeing how the Insight Biobank can be used like in real time to help real research that's happening like now, not like in 20 years. And I think that's one of the things that we as patients like really want, right? Especially when we're kind of those like people who understand more of the gravity of our disease, whether it's because you're metastatic or you're higher risk. Like we want to know that the research that is happening in our lifetime. That that it has a chance, right, at helping us, or at a very least helping somebody very soon, like after our time of being diagnosed.
And I think
So,
that's so
oh, go
critical.
ahead.
I really do. I think that's super important that we're getting things that are actively happening right now. And that's one of the great things about having these organoid models and being able to generate them from patients sort of in real time within weeks, so that when we have valid drugs that we can test, we're going to be able to feed back that information quickly.
Yeah, like it's super exciting to see like science come together. What are some of the models that you've been growing? Um, I guess let's backtrack. Maybe give a little bit of a summary of like what does that mean? Like these models that you're growing in the lab. What was kind of the original founding idea behind growing these models, and where are you at with the growth of them, and have you done any testing?
Yeah, thanks for that great question. We have first started this really just out of the idea that our uveal melanoma models currently existing in the lab that most people use are clearly not working well for what we need for our patients. We have seen over and over and over again that we have really exciting, promising results in the laboratory, and we make it all the way to a clinical trial, and that clinical trial unfortunately has some disappointing results. And so, one of the papers that we published recently, we actually did a comparison looking at our traditional commercially available cell lines. We looked at our organoid models, and we looked at our organoid models broken down into a two-dimensional culture as opposed to the three-dimensional culture. And what we found is that the traditional commercial cell lines that you can buy off the rack for uveal melanoma tend to be very sensitive to drugs. And that may be artificially so, such that that could explain at least part of why we're not seeing some of the results that we have wanted to see in historical clinical trials for uveal melanoma. Our models tend to be a little more treatment resistant. So we looked at several different drug combinations that we know looked really good in the lab and then ultimately didn't work out for patients. And we showed that our models, compared to the off the rack cell lines, are actually more representative of what we saw in those clinical trials. And then we looked at some newer drugs. The drug that we chose for our surrogate positive control is the darovasertib drug. And we saw that we definitely do have some subtypes of uveal melanoma that are more sensitive to that. That's consistent, not only in the off-thorax cell lines, but also in our models as well. So this gives us a lot of hope that the models we're putting out there that we're now sharing with other researchers are actually going to be more representative of what will happen in the clinical trial phase, so that when something works in the lab, hopefully we're actually going to see that pan out for our patients in the clinic.
I think that I had no idea that you could purchase, as a researching team, as somebody, trying to get to a clinical trial with drug development, that you could like purchase uveal melanoma cells that have just kind of been, like you said, potentially artificially grown, or like, we've copied it, but like, have we really copied it? Because like you said, if you're experiencing good results in a trial of the drug on just cells, but then you're taking it to people and you're not seeing the same result at all, then like there's a big disconnect there. So I love the idea of using the living library and just using the models that you guys have been growing to bridge that gap, right? Because it's so sucky, I'm sure, for drug developers to just be like, well, it worked. It worked so well in the cell lines. Why isn't it working for the people? And so, I mean, it sounds like ultimately it would be really cool if like every clinical trial was able to test their drug against your cell lines, against the living library, against, tissue from the biobank, tissue that is like from living ocular melanoma patients. Oh man, I love the direction that this is going. It's so cool.
And that's exactly the hope. The hope is that we sort of skip these false positives. We don't subject patients to things that ultimately aren't going to work, and that the models we're using in the lab really behave and represent what we're seeing in our real patients, and that they're not something that's been in a dish for decades now that has mutated and no longer behaves like the cancer we see.
Yeah. Well, and like when I think about this from a clinical trial perspective of like, okay, you start with like a phase one, right? Phase one is typically we've gotten past the cell lines. If and you can correct me if I'm wrong, but I've been kind of thinking about this and ruminating about clinical trials for my own purposes. But phase one is when there might be some kind of drug escalation, but ultimately it's just, is the drug safe? That's the goal of that. So if they're doing the drugs against the cell line first, and they happen to use it, in a cell line from like the living library, one that is like more unique to uveal melanoma itself, not something that is kind of grown to be different over time. Then is it possible to like kind of go into, say, a phase one trial with more confidence that you're going to be able to treat patients? You just now need to figure out what dose is safe for that. I don't know if that makes sense.
No, that's a fantastic question. I think that is exactly the goal. We're going in hopefully with better hope of efficacy, that result we saw in addition the lab is going to actually translate to what we see in reality in our living patients.
Aura Biosciences is a clinical stage biotechnology company focused on developing precision therapies for solid tumors that aim to preserve organ function. Our lead candidate, Belsar, is currently in late-stage development for primary choroidal melanoma and in early-stage development in other ocular oncology indications and bladder cancer. Our mission is to grow as an innovative global oncology company that positively transforms the lives of patients. For more information, please visit us at aurabiosciences.com.
We also have some in between steps that we can do that may also support phase one clinical trials. So we have been able to create small animal models of uveal melanoma that actually use our organoids from the living library. And so we can create eye tumors that we can actually get fundus images and OCT images, just like we would monitor tumors in human patients. And we can get little miniature CT scans so we can monitor the liver and monitor the lungs. And so we can actually track tumor progression in a living model in the lab. And that living model, beyond what we can see in a dish, will also allow us to get some safety indicators. And so we can not only support hopefully having more effective therapeutics going into clinical trial, but hopefully having some good data that those are also safe.
Yeah, that would make a huge difference, I think, especially for those like phase one trials that are just trying to get off the ground. If there was more kind of backing choices and backing, whatever it is that they're putting in front of patients as, hey, we've got this drug, we've got this combination. We really think that this is a good idea. We need, 15 clinical trial participants to get this going. We need, a maximum of 75. Like the enrollment, I feel like it would be easier to enroll as a patient with metastatic disease myself. It would be easier to enroll in a clinical trial that is in phase 1. Because phase 1 to me right now, like when I think about it, it feels like we're throwing a noodle at the wall or like we're just taking a shot in the dark because there's no data around uveal. But if we can come into it with some kind of clinical data that says, no, 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 we do have response in uveal. Here's where we got that response. And because of this case, this case, this case, this case, like these, these examples of where we were able to put the parallel of the organoids next to the actual response rate of the patients, like that just lends itself to so much more confidence going into a phase 1 clinical trial. And I mean, I would hope that trials would get to move faster because patients wouldn't be so terrified of joining a phase 1 trial.
I think that's a fantastic goal. I think rapidly accelerating what we can offer to our patients is really a huge impetus for continuing to grow this. And it's not just all uveal melanoma generically. I think one of the wonderful things about having built this living library, we now have more than 50 different models from different patients. And so these things have different molecular profiles, they have different gene expression. And so we're actually able to represent a variety of different personalized subtypes of uveal melanoma. And we can see when we do drug testing, some of those subtypes might be very sensitive to a certain drug. Some of them might be more resistant. Some of them might need a particular drug combination. And so we actually may be able to predict which subset of patients are going to most benefit from being on a particular trial so that we can more quickly direct those medicines to the right patients.
Yeah. Like, so it's not just put the call out to everyone. It's no, 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 we need patients with this, 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 and this. Like these are the main criteria. And it narrows it down so much. Like I literally was reading a clinical trial breakdown yesterday, and I kid you not, it just had this like giant list of things. And in the list of things happened to be one dot that said uveal melanoma patient, like as one of the criteria of eligibility. And it's like, okay, well, that doesn't tell me much. Like what type of uveal patient are we looking for? And in the metastatic community, I'm sure like we have HLA-A*02:01 and PRAME, that there's plenty of trials that have been kind of circulating and continuing through that are focused on those two expressions, but not everybody has those expressions. And so then the rest of us are left sitting here like, okay, but what about us? So I think it'll be really neat to see how this can evolve and just really change the landscape of like how we approach clinical trials, both as patients and how you guys approach sending patients to clinical trials, based on characteristics that are deeper than just you have metastatic uveal melanoma.
You're absolutely spot on with that. And so it's my hope as this grows, it's really going to be a public community facing resource so that companies or researchers who have something that might be interesting to test can actually do that, and not in just one subtype of uveal melanoma that might not represent most patients, but in a panel of subtypes so that we're going to know, okay, this works maybe for X, Y, and Z, but maybe not for A, B, or C, but this one's good for A, B, and C. And so it's really, I think, the beginnings of what's going to be a rapid boom. We've seen the clinical trial boom now is happening in uveal melanoma. Finally, after decades of not doing really any of these clinical trials for patients in this particular disease. So now I think we have the models that are going to support this really coming forward at a much more rapid pace, just as you said.
Okay, so I have another question. I know your living library has been organoids that were taken from the original eye tumor, correct?
We started with that and we have actually expanded. So
okay, so we're taking liver tumors or whatever tumors now?
We are taking metastatic tumors as well. So we have some liver metastasis in our biobank. We also even have some lung and bone metastasis in our biobank as well. So this is going to open really a new frontier to see our metastasis different in different locations. And we have some organoids that are from the same patients from their eye tumor and paired with a liver metastasis. So we can actually study how these tumors evolve and change over time. Because another one of the problems that I see that happens a lot of times with uveal melanoma research is most of the off-the-rack cell lines are from primary eye tumors. And it's great to have something. It's great that they grow and that we can work with them. But those, again, may not represent metastatic disease, which
Yeah.
is really one of the biggest areas of need.
Yeah, absolutely. Okay, so say somebody had a biopsy like, 2 days ago, and they did 6 core samples, is what they told you. Like, is that a sample from a metastatic biopsy that you can work with? Like, is it worth it for that patient if they wanted to like get that sent to you? And if so, like, how does that process work?
So we have a nationwide protocol now, so we can consent a patient from anywhere in the United States who wants to send us tissue from a biopsy sample, and we can generate an organoid for them. The best way would be to contact us before the biopsy happens, because the best way to give us a great chance of growing a really good organoid is to actually have the kit with the cell preservation media shipped and available to that person doing the biopsy the day of biopsy. That way, the tissue that you don't need for a clinical diagnosis or clinical tests can go directly in that preservation media, and then those can get overnighted to us on ice. And we've had really good success generating organoids when they're shipped to us overnight.
Castle Biosciences is a proud sponsor of this I Believe podcast. Castle's innovative uveal melanoma tests provide valuable information about the risk of your eye cancer spreading to help you and your healthcare team individualize the management of your disease. To learn more, visit castlebiosciences.com.
Yeah, that makes sense. So I guess I'm just thinking, like, in my particular case, maybe not going to work unless they happen to preserve it really, really well the last 2 days. But I could always ask.
You can always ask. Yeah, it depends on how
Yeah.
things are preserved. Once things go into formalin, then we know the cells are not alive. That doesn't mean
Yeah.
that we can't do molecular testing and find like a twin in the biobank that has a very similar profile to a particular tumor that could be tested.
Yeah, I guess that's like still worth a shot. But knowing about it going into a biopsy, I think that like sometimes the challenge is that, as metastatic patients, if you have metastatic disease show up in a particularly odd location, like that doesn't really hit the markers, like, okay, liver, lung, bones, maybe lymph nodes, maybe the skin, like, but those are kind of the only 5 that really tend to come up. And then you have just other random spots, like literally anywhere. And we understand that, from a micrometastatic perspective, obviously that's how this disease works. But going into, a biopsy and having something show up in a bizarre location then kind of layers that situation. I think, at least it did for me, like with some question of like, okay, but is this primarily uveal melanoma, or is this something completely different? Is this a cyst? Is this like breast cancer? Or, just there were like more questions just because the location was not conventionally heard of. So anyway, sounds like it would be smart, at least if you want this level of contribution to research, it would be smart if we just make sure that we reach out for that kit ahead of time and just have it on hand. Like, worst case, we send it to you and you're like, hey, actually this is not uveal melanoma. Never mind. But is it something that comes uniquely from your clinic, or is it something that's linked to the Insight Biobank now?
Currently, for the organoids, we are shipping from our center. I think the Insight Biobank, my hope is that we can grow that and have a partnership where we're able to generate those organoids for them. Insight is great at storing things, but an active lab is needed to actually initially generate the organoids and then expand them so that we can create the stores that we need to later share with other researchers.
Yeah, for sure. Oh my goodness, so many things to think about. But this is all really really good stuff, really exciting. And I'm excited to hear that you guys are expanding the organoids to include the metastatic. And it'll be really interesting to see any of those patients that you're able to line up tissue from the eye, the liver, and any other locations, like and see the differences. I did have kind of a funky question. When you say you test the drugs on an organoid, like what does that look like? Do you have like, I don't know, do you have a petri dish full of cells that you can see and you just drop the drug on it? Or like, what does that look like?
It is very much like that. So we have really specialized petri dishes that have lots and lots of wells in them. So we usually do these in a miniaturized format in a 96 well plate. So it's basically like a rectangle that has 96 teeny tiny little petri dishes in it. And then we can grow up really little itty bitty organoids in those. And so we can do a variety of doses of the drug since we have 96 slots, or we can do some different drugs since we have 96 slots. And often we will do a panel of organoids that are different on that 96 well platform. And usually we are applying the drug, we're letting the drug work, usually for 3 days when we're doing things in a dish. And then we can check viability, or we can check live dead, and we can look at the cells under the microscope and actually see if we still have healthy organoids or if they've kind of shriveled and shrunk and died.
Yeah, for sure. So like looking for that response. That's really neat. And like, I mean, it just feels like science in science class a little bit. Like, I mean, obviously way more advanced, but like I remember we like did swabs of gross germs around the school, and then we like, stuck it on a petri dish, and the goal was to see like how germy could we get it. And some of the germy locations were surprising. But like seeing the kind of just the layout of how you guys are able to just very meticulously test, not just one cell line, but like various organoids and the way that they respond. I really think that it's game changing, and I hope it continues to be game changing for the remainder of the treatments that we have, on the table, and hopefully continues giving us answers as to why some patients respond better to, say, PKC inhibitors versus immunotherapy of a different sort. And all those answers are obviously still in the works, but I'm so grateful, Dr. Dalvin, for you for like being part of this and for just conceptualizing this and bringing it to life, literally. I think it is one of the coolest ideas in science that I've ever heard of.
Thank you so much. I'm really excited about it too, as you know, and I probably expressed before. I just feel that changing the game and contributing to better treatments and hopefully cures for patients with uveal melanoma is such a big purpose in my life. And I really hope that from early in my career to mid-career to late career, everything is going to be completely different about this conversation, and we're going to have so much more hope on the horizon.
Yeah, absolutely. Okay, so final little finishing touches. If someone wants to get a hold of you because they know they've got a liver biopsy coming up, or whatever type of biopsy in the metastatic world, and they want to make sure that they can get a sample to you, what's the best contact information? And we can also put this in the show notes for them to be able to reach out.
Yep. Email is probably the best way, and then I may connect you with my research team so that we have logistical support. But that's dalvin.lauren@mayo.edu.
Okay, awesome. Well, Dr. Dalvin, thank you so much for being here today and chatting and giving us an update on your living library of ocular melanoma. And we look forward to seeing where you go in the future. Thanks.
Thank you so much for having me.